Today we will study depth buffer algorithm, that is Z algorithm, used for computer graphics. This algorithm is used for hidden surface removal. So the objective is to study depth buffer algorithm for hidden surface removal. In this depth buffer algorithm, the following steps are followed. It maintains the depth for each pixel. All of the elements of the Z buffer are initially set to be very far away. That is, generally in programming, some large value is used. In the pseudocode, we will represent it as infinity. Whenever a pixel color is to be changed, the depth of this new color is compared to the current depth in the Z buffer. If this color is closer than the previous color, then the pixel is given the new color and the Z buffer entry for that pixel updated. Else, if this color is not closer, the pixel retains its old color and the Z buffer retains its old value. In the algorithm, the Z buffer is maintained as a 2D array. This 2D array stores a depth value for each pixel. For example, initially init screen operation is performed. That is, the screen is a 2D array of size n by n. This screen array is initialized using for I equal to 0 to n and for j is equal to 1 to n matrix with background color, and simultaneously the Z buffer, which is also a 2D array, is initialized to infinity. Then draw pixel operation is performed. This draw pixel takes x, y, z components of the pixel and the color. So if the z component of this pixel is less than equal to z buffer xy, that is, it is closer, then the z buffer is updated to this new z value of the pixel and screen xy is updated to the color of this new pixel. Let us understand with the example. So this is the Z buffer which is initialized to infinity, and this is the screen which is initially empty. Then first this purple object, that is triangle, is considered, where all these three vertices of the triangle are having same Z value, that is 5. So this portion of the Z buffer is initialized to 5 as shown here. So this portion of the Z buffer is initialized to 5 because 5 is less than infinity. So the screen will look like this. That is, the whole of the purple triangle is visible to the observer. Then the second object is this orange triangle, which is having different Z components. That is, this portion of the triangle is having the Z component as 7, and when you move in this direction and in this direction, then this particular coordinate is having Z component 2. That is represented these decreasing Z values. So the Z buffer is updated for the corresponding pixels like this. Here, if you consider this portion, then for this portion, for this portion here, the Z component was already infinity. So 7 is less than infinity, so it is updated to 7. Hence, orange is visible here. Then Similarly, this 6 is less than infinity. So here the orange color is visible. Same for this remaining portion. Now, if you consider the remaining pixels, for example, in this portion, then earlier here it was 5, that is for purple object. Now for this new orange object, the z value is 4 because 4 is less than 5. So at this portion, this 5 is replaced by 4, and hence in this particular part of the screen, orange part is visible. Like this, the Z buffer is updated and the screen will also be updated. So only this portion of the purple object is visible and this portion of the orange object is visible. Like this, the Z algorithm works using the Z component of the object. Let us see another example of Z buffer algorithm. Suppose we want to draw these two objects, that is yellow and blue component. Yellow component is having z value 0.3 and z component is having greater value 0.5. That is, if this is the direction of the observer, then whole of the yellow component is visible to the observer and this particular portion of the blue component is not visible to the observer. So the correct final image will be like this. So when the algorithm will consider, suppose the blue portion is drawn first. So initially the depth buffer, that is Z buffer, is initialized to the largest value, that is 1 in this example. Then let us say first blue component is drawn. So because blue component is having Z value 0.5, which is less than the initial value 1, so this portion of the Z component is updated to 0.5. So whole of the blue component is visible. Then yellow component is considered, which is having Z value 0.3. So this portion was having 0.5 earlier, but 0.3 is less than 0.5. So this part of the Z buffer will be updated to 0.3. Hence, the screen will have this portion of the component as the yellow color. So the correct front view will be seen by the observer. So like this, the Z buffer algorithm will work. The advantage of the Z buffer, that is depth buffer algorithm, is that it is especially useful when it is difficult to order the polygons in the scene based on their depth, such as shown in the figure. Here there are three strips, one above the other, so it is difficult to understand and draw. But depth buffer algorithm can handle such object as well as this object properly. Z-buffer algorithm is having the advantage that it is simple and easy to implement and it is amenable to scanline algorithms. It can easily resolve visibility cycles. Also, Z-buffer is having some disadvantages. For example, it does not do transparency easily. Also, in the Z buffer, aliasing occurs. That is, since not all depth questions can be resolved, aliasing occurs in the Z buffer also. Anti-aliasing solutions are non-trivial. Shadows are not easy to handle using the Z buffer algorithm. Higher order illumination is hard in general. These are the few references which are used to prepare the presentation on this Z buffer algorithm. If you are having any doubts, please feel free to ask. And if you like this video, do like and share the video. Thank you.